Hello everyone, how are you guys? Welcome to GFG. Welcome to the 21 days DSA Habit Builder program. How are you guys doing? Kindly confirm if I'm properly audible because I've changed my mic today. All right. Can you kindly just write in the charts if we are ready to go? If we can start the stream. Hello Jay. All right. So we have enough audience, I think, and we should be beginning. But before we begin, let's talk about the yesterday's class first. Do anyone have any confusion in that, or just in general, how was yesterday's class? I hope you guys were able to process all the concepts that we discussed in that. If you attended previous class and if you are attending this class, then don't worry. This is slightly a different class and it is going to be beneficial for both the people who have been attending continuously and if you have joined today as well, you're going to enjoy it. And as you might already seen the title of the video, it is going to be journey into binary trees. So we are going to be beginning with binary trees. And binary trees is one of the most favorite data structures that I have, and I hope so. After today's class, you are going to feel the same. Okay, so kindly just for the sake of it, so that I know who is attending this lecture for the first time, like who has not been a part of the series and they have just come up to this lecture. Write +1 in the chats. Those people. Okay. Okay. We have Arun that has joined for this class only. Okay, Arya. All right. So I hope these are the new people. Rahul too. Okay. So I would want now some of the people who have been continuous in this journey to write yes. Who have been continuous in this journey. Just write yes. Okay. Okay. Now we will be beginning with binary trees today, but just to let you know that when you are going to dive into binary trees, you should have a uh, clear understanding of recursion. Okay, recursion and a little backtrack because if we go deep into like some of the hard questions of trees, we do require that. All right. So for that, I believe you guys are prepared for it and you are going to, in sync with me, solve all the questions. Again, the requisite is that you should be attending this session with your laptop so that you can code simultaneously with me. And you should also have a pen and paper by your side so that whatsoever we are discussing, you are able to draw it on the paper, able to make your own points, write your own points, and that is going to definitely help. Okay, so I think we are good to go. Just for 1 second, let me fetch the link for the first question and give it to you guys. Just a second. This is one of the very basic questions of binary tree. We are going to deal with it. Okay. I have posted the link of the question. You can open that. I'm going to give you 2 minutes. Go read the question, then just quickly come back here and write a comment summarizing what you have understood, what the question is asking. Okay, I'm giving you guys 2 minutes. Hello, Srinivas. I was waiting for you. I've posted the link of the first question. You have to go check that question out. Then, once you are done reading the question, come here in the chats. Tell me what you have understood, what the question is asking for. Okay. We can use BFS. Yes, we can. But it would be better if we go with the use of recursion because we have been following a path. We studied recursion, then we went more like deeper inside it. We learned about backtracking. In this lecture as well, we are going to be using a combination of everything. We'll be focusing more upon recursion, and then whenever we need BFS as well, we are going to take help of it. Okay. So what can I do, Ajay? What are you asking for? I've asked you to read the question, and once you have read the question, just quickly in the chats, tell me what the question is asking for. Everyone, the time is over that I allotted to you guys, so I'll be beginning soon. Uh, you can just post your comments here. I'm also seeing the comments. Okay, let's begin. Here. Okay. All right. So the height and width are the same. Sometimes yes, but we will see the concept of it. Don't worry. It is just different ways of saying the same thing. That's all. If you count it from top to bottom of the tree, it will be called a step. And if you are seeing the perspective of the last leaf node till the root node, then it will be called as a height. But both the values are going to be the same. Okay. All right. I hope the screen is visible to you. Is it? Kindly tell me so we can proceed. Okay. So we are here. And this question is very simple. It is a straightforward saying you are given a binary tree, you have to find its height. Okay, nothing else. And here if you see, don't need to read any input or print anything. Your task is to complete this function, height, and which it is saying which takes the root node of the tree as input parameter and returns an integer denoting the height of the tree. If the tree is empty, it returns 0. Okay, so we are going to design this function. But before designing this function, for everyone who who is not very comfortable with trees, I'm going to give a little introduction of trees. It won't take much time. Okay. So we are here. Orange. Oh, I've shared this one. Yeah. So if we have to make up a binary tree, what we can say? What we can say? We can arrange these like this. Okay, so now let's make it more clear by making the connections. I hope most of you guys already know what trees are, correct? And the structure that I have made is a combination of two things. Okay, what are those two things? First are nodes, and the other are connections or edges or anything you can say. Okay, so let's say if this is the very first node, all right, we call it as the root node. This is the root node. Okay, and all the else are the all the else levels inside the tree are internal. Just the last ones, every node that is at the last, I mean this node, this node, this node, these nodes are called leaf nodes. Just getting you clear with the basic terminologies. And every node which lies inside this, if we talk about this node, and this node, these are called as internal nodes. Okay, I hope whosoever is learning it for the first time, it is clear to them. Yeah. Again, we are going to make it an open conversation. Wherever you feel that you have any doubt, just post it in the chats. I'll be taking it from here because I am on the other screen. I have a chat screen. All right. So I hope this is clear till here. If I am asking the question, please try to respond with yes or no in the chats. Okay. So once we talk about um, this tree, this is the root. All right. What are the conditions for a binary tree to be called as a binary tree? Okay, first of all, a tree data structure is there, and then if we put some restriction on that tree data structure, we can obtain a binary tree. All right. What are those? Restrictions? The main restriction is that every node, every node must have children between uh, between this. All right. So what do we mean by this? That either a node can have no children, or it can have one, or it can have two. Simply three values. It can either have zero, it can either have one, or it can have two. Or we can say, in other words, at max two children nodes. Now, what I'm saying by like, what do I mean by children node? Okay, if this node is here, and if we're talking about the direct connection of this node, these are going to be called as child nodes of this this parent node. Okay, so this is a parent node. It has two child node. We can also say that if you're talking about the levels, these could be called as level. This is level one node. This is level two nodes. These are level three nodes. And this is a level. These are level four nodes. But that is not a thing that we are going to be talking about. That is when we'll be doing BFS and all. Right now, just remember that we have parent nodes and we have child nodes. If we talk about different scenario, let me bring all this up first. If we have a different scenario, just draw it. Yeah. Assume if we talk about this node, for this node, this is the parent node and it has two children nodes, this one and this one. All right. No problem, Srinivas. Thank you for acknowledging it and mentioning that. You can. I hope. Okay, so let me just make it clear that there has been three to four students who have been very regular here in this class, and they have helped me a lot in conducting these lectures and for making it interactive. One of them is Srinivas, and he, due to some work, is leaving today. And I hope If he is leaving, we are going to get some more people who are going to be making it as engages as they are making. All right. So be attentive in the chats. Okay, we are done with it. Now we know what a basic tree looks like. What are the terminologies that we use for it, right? Now, with the first question, we are going to be getting the clarity of how we are going to approach any problem in binary trees. What is the first problem? The first problem is to find out what is the height of the tree. Okay. First, let's go with human intuition. First, let's figure out what height actually means. I've drawn the same tree again. Now you guys need to tell me what is the height of this tree just by looking at it. We're not talking about any program, we're not talking about any intuition, how you're going to code it. I'm just asking you, see it and visually tell me that how, how many, like how much height it has. What is the height of this tree? I'm waiting for the answer. Difference. Okay, it is 4. Okay. Archie has said that. Manshu has said 3. Maria has said 4. Okay, we do have a conflict. Joe is saying it is 3. Pratik is saying it's 4. Let's see who wins. Any more answers from anyone? It's looking like a poll between 3 and 4. 3 has gotten 2 values, 4 has gotten 3. Let's talk about it. Anybody else? Okay, Ashutosh is increasing the vote for 3. So now we are at equal of 3-3. All right, let's discuss. Height. Sometimes it is very conflicting, as we can see in the charts. Some people say height is the measure of the maximum length we can have from the root node to the last leaf node, or we can say to the last level leaf node. Okay. Now, when we are talking about path, when we are talking about path, it could be number of nodes lying between it, or it could be number of edges lying. Right? This conflict has been very long. Okay, so there is no way it is going to have a conclusion, but we are going to discuss it. What happens? Some people say that first of all, let's find out the longest path. What is the longest path? Let's make it clear. It is this. Correct? If I talk about it, it's this path. It's this path. It is the longest path from from the root to one of the leaf nodes. This is the longest path. Now we can count two things in it. Either we can count the number of nodes, which will result in 1, 2, 3, 4, which many of you guys are saying, or we can count it in the number of the edges, the green lines, which is 3. It is very conflicting. Whatsoever the problem is, about the coding portals, try both the things. Okay, whichsoever is accepting the correct answer, go with it. Because this is a confusion. You can not a confusion, but it is clear in everybody's head, and everybody do accept that yes, this goes like this. Some people believe it to be number of edges, some people believe it to be number of nodes. And sometimes it is specifically mentioned in the question when they are talking about height, they are talking about number of nodes, and sometimes they're talking about number of edges. But if they are not talking about it, just in the question that we read, we can try both the things. All right. So by human intuition, you got to know, yes, by just seeing it, that the height is 4. But if we have to see it in a more programmatic way, we have to think computationally. What could be the approach that we follow? Any suggestions to people who might already know what trees are or who doesn't know anything? They can post as my email. because now you're gonna learn. Don't worry. All right. I'm asking for the intuition from the people who already know trees. Yeah, Malia, it is going to be dangerous. That's true. Right. Right, Akshay. Okay. To the people who are learning it for the first time, let's discuss how they are getting to this conclusion and what are the fancy terminology that they are using. Okay, let's see. Now, one thing should be very clear in your head that whenever we are talking about trees, the very first approach that you should think of it should be a recursive approach. All right, and by recursive approach, what do I mean? You need to break down your problem into simpler problems of a smaller size. Very, very clear and concise definition of recursion is you have to break down your problem in smaller chunks and then you have to solve the smaller chunks. Once the chunks are solved, you'll be able to make your big correct answer. Very simple. But how we are going to apply that here in trees? Because we remember whenever we talked about arrays, what did we do? We solved the question for the first block and we set the rest block in the recursive call. This is what we used to do. Correct? Now, when we have trees, how we are going to use recursion? The question arises, right? Now we are going to break the trees into subtrees. Okay. Now, what is a subtree actually? So assume if this is the whole tree, and I talk about this portion of it. Okay, this portion of it. This portion would be referred as left subtree with respect to this root node. All right. And now if I talk about, let me change the this. Yeah. Now if I just talk about this tree, this is also a subtree. It could be treated as a complete tree in itself when we give it as a parameter inside a recursive call. Okay, we'll see how that works. But here, when we're talking about this yellow dotted area, what do I mean by that is, with respect to this node, this is a right subtree. All right. Now, once you are clear with it, what subtrees are called and how subtrees work, basically what subtrees means, you can type Y in the charts very quickly. Y for yes, very quickly. And even you can type N for no if you did not understand what it is. I'll explain it again. Very quickly, please. Okay, you understand it, Arushi. Good. What about other people? There are so many people today. All right, Prateek, Maria, Sahil, good. Sahil is here. I remember from yesterday. Ashutosh too. And Prateek is always, yes. Okay, you guys understand it. Malia does not. Malia, can you please specifically mention what did you not understand? Just what is your query? Uh, just write it there. If you're not about if you're asking about subtrees, if we have this big whole tree, then just a smaller part of this tree will be called as subtrees. This is the left side of a tree. This is the right side of a tree. With respect to this, okay, this is the root node. With respect to this root node, we call this child as left child, this child as right child, and this whole subtree as left subtree, and this whole subtree as right subtree. Okay, I hope I was able to answer that. Okay, let us move forward with the intuition of this problem. How we are going to approach this problem. All right. Okay. So now once we have this, Let's see. Root has to work for only itself. Okay? Root has to work for only itself. And one more thing. Once you are standing in a node, assume you are standing here in this node, then you are only able to see your child nodes. Okay? Then your left child, your right child. Once you are standing on any node, you are visually only able to see two nodes, or you can say only the nodes which are directly connected to that node. Okay? If two nodes are connected directly to this node which you are standing in, which you are at right now, you can see only these two. Okay. Once if you can only see these two, can you figure out the height by itself? If you are able to see these nodes, you for yourself say that only this is a tree. We don't know what further is. We don't care about it. We only see that this is a tree, and for this being a tree, can we say that the height is just one? Can we? Can we or can we not? Just type in yes or no. Can we say that the height of this tree is one or not? For us considering about the edges, right? Can we say that the height of this tree is one, considering the number of edges? Yeah, we can say that. All right. And everybody else, there has been more people. Okay, Varun was there who answered. Joe was there who answered. And Sherry was there who answered. Okay. All right. All right. All right. Okay. Arthur is there. Now, now, just give me a second. Yeah. Now let's see. If we are able to figure out the answer from this, what modification can we make that we do not have to fall further and we can conclude the answer from here? What? Okay. If we see this subtree as a completely whole new tree, our problem will be reduced, correct? Our problem will become smaller. Then in this tree, we will be standing here and we will ask what is the height of the tree. When we are standing here, we again would be able to see till here, till these two nodes. Here we can say we have height of 1. Again we can say that, right? Once we call it to this node, again it will see further, it won't be able to find out any nodes further, right? It won't be able to find out any nodes further because they are not. Correct? So this will say that I have a height of 0. This node will say that I have a height of 0. Correct? And when again you are standing here, still you are standing here, you made this move, you got the answer to be 0. Then we are still talking about this perspective. Then we'll check out the height of this subtree as well. When we are checking out the height of this subtree, the problem again will be broken into smaller part, smaller problem. Then when you'll be standing here and dealing this node as a root node, then you realize you again can see only one node further. And here you will say that the height with respect to this node is also 1. So far we can see. Okay? Till the point we can see. Again, we'll say go further. We'll ask this node go further on and calculate the height that you might have. This node, standing at this node, we won't be able to see any further because there are no nodes. This will say that my height is 0. Now this is the base case. Now we have returning answers. What does that mean? Even if you are unable to get it, don't worry, I'll be repeating it. But go with the flow. This will say that my height is 0. When we will conclude it that I'm standing here, I know that my height is 1 and furthermore it is 0. That means we can do 1 plus 0. that would result in 1, and we can return 1 as the answer of this subtree. This will be returned here. Here we had the answer to be 0. This answer will be returned here as well, 0. And from this side, okay, it is getting messy. All right. From this side, we received 0. From this side, we received 1. Now, when we are standing at this node, we have perspective of this subtree. We are saying that from one side, it is saying that their height is 1. From the other side, it is saying that its height is 0. What is the height? What should be the height? The height should be the one which is longer. The height should be the one which is longer. So which is the bigger value? 1, right? We are going to take that into consideration. We'll say that this subtree has the is giving us the real height. We will have that 1. This node also know that its actual height with respect to only this tree is 1. So with its height plus with its subtree's height, we'll have 1 plus 1, and the height of this subtree will be returned as 2. Okay? Is it clear till now? I don't expect it to be clear yet, but I'm again asking to the chats that if it is clear till now. If yes, you can type Y. If no, you can type N. My second explanation would be depending upon the number of N's. Higher the number of N's, I'd be repeating it more intensively. Okay, Mali understood it. Sahil understood it. I'm waiting for more people, okay? Be very responsive. Joe understood it. And more people? All right. Everybody understood. We are having a very smart audience. Okay. So I think if nobody has problem with it, we shouldn't be repeating it. But on a high level, I'll just go through it once more because it has gotten very messy. Now, once you have received 2 from this side with respect to this subtree, now what do we need to do? Are we done with it? It is the answer only from one subtree. We have not yet got the complete answer from the other subtree as well. And I'm talking about when we are having the perspective of root. We were making all the calculations till we were having perspective of this node. But now we are talking about the real answer that we have to return. And that I'm asking when we are here at the root node, we have gotten the answer from one subtree, which is 2. We still have to calculate that what answer does this subtree give to us. All right, what answer does this subtree give to us? Again, I'll be making call upon this. We know that our actual height is 1. Whatsoever the height comes from this side, we'll include 1 in it, we'll add 1 in it, and we'll pass on as the answer. And this root will consider whichsoever height is longer, and that will be returned as the answer to the function. All right. This is this again. When we are standing here, this will see that we can only see one edge. If it had the other node, we'd be able to see on the 2 sides, but we are able to see on the one side only because it has one node. It will conclude for itself that yes, I do have the height of 1. Let's see what height my subtree has. Its subtree will be returning 0 as a height because it does not have any further nodes. When it returns 0, this will realize that the total height is going to be 1 plus 0, which will be 1. So this side will be returning 1 as the answer. Now again, talking about with the perspective of root node has gotten 2 values. From one subtree, it has gotten 2. From the other subtree, it has gotten 1. And actual height, the height that it can conclude is 1. So what we'll do, we'll take the bigger value of these, 2 or 1, definitely 2. We'll include plus 1 to it. That means we'll include the height of itself to it. And the final height would be 3. All right. I hope everybody understood it. Everybody has already said yes. Okay. Now we are going to talking about. Now we'll be talking about how we can write the code for it. I'm going to tell you the approach, and make sure you follow it the same way. Because once you get the flavor, once you get the essence of it, that how a recursive code particularly of a tree is written, then there is nobody stopping you to make your own modifications to it. Okay, this is sample tree that we have taken. There was one more node here. All right. Well, so far I have not put any values inside these nodes, but obviously nodes are never empty. They do have some data inside it. Just for the sake of height, we don't care about the data. Okay, as the question said, we have a function, and has it has the root as a parameter. It has the root as a parameter. It has root as a parameter. Correct. Now, what do we need to do? Again, we are going to write a recursive function for it, and the recursive function of like obviously it always has one base case, one work that we have to do, and the recursive calls. Okay, every recursive function has three parts: the base case, okay, and the next is our own work that we have to do for one step, and the work done by recursion, or we can say recursive, see, recursive calls. Okay, these are the three basic, you can say, parts of your simple recursion program. And these things can be flipped. Base case is always at the top. These things can be flipped. If you're making recursion calls at the last, it will be called as a tail recursion. Okay, and we can switch it. We can do our work later, and we can make the tree. We can make the recursive calls do their work first. Both could be the things. Now let's see. Now let's see how we're going to write the code for it. Again, as always, we are going to talk about the base case later, but let's see. Firstly, I'd want that I have a variable, just like we were doing. If we are standing at the root, we were expecting the left subtree to get whatsoever height it has. We were expecting the right subtree to get whatsoever height it has. So I'm just going to write the same thing. I will say, I will say, I have created a variable called L, and I'm calling the same function again. Okay, I'm saying L, give me the height of left subtree. This is how you're gonna ask for it. You'll say, okay, root.left will be referring to this node, and you'll send this node as a root node to the function again. And you'll ask for the height of left subtree from here. Then the next variable will be for right. I'll again do the same thing. This time I'll pass on the right subtree as a parameter to the same function. These are the two recursive calls that we are making. We are asking it to get the left height. We are asking it to get the right height. Now what we are going to do? We know that we have to add 1 to it because we are talking about the own level. Whatsoever we get, first step is to figure out which value is bigger. So whatsoever value is bigger, we are going to add 1 to it. This is the simple formula. This is the simple funda. Now what we will do? We'll compare. Okay, max is a function which gives you the maximum value of both the things. Correct? So we can say something like that. Okay, what is the height? Height is maximum value of L or R plus 1. That means the height that we have. All right. Now we have to return h, return the height. This is a very simple code for a tree, for a recursive function. We now know how we are going to break the tree into subtrees. We are again going to have a try run now. Now you'll be understanding it in a better way. You might be thinking why I am wasting so much time in this simple question. But believe me, when we are going to get to the next question, we are going to be taking lesser time because all the concepts will be clear then. Okay. Now let's. I hope you guys know how recursion works. But still, I'm going to consume 10 minutes of you more because I'll be including a recursive stack now. I'll be including a recursive stack now. And because I'll be maintaining it, let me give it some values. All right. I've given some values so that we can actually see how the recursive calls are working. Okay, so the very first recursive call would be height. I'll just say h. Okay, height, and inside the bracket we are passing the root. That means a. Okay, once we have come here, the very first thing that we will see, I will still not written the base case. Remember, we'll write that later. The first line that it will come to will be this: L is equals to height root dot left. The next call that will be made in the call stack, in the recursive call stack, would be h b, because we are sending root dot left. What is root dot left? B. All right. Again, we will get to this function. Okay, with a different frame, we'll get to this function. This is at the top now. Whichsoever function is at the top of the call stack, we'll be referring these lines for that function. Okay, now for HB, for height of this B, we are again here. We are again here. We'll end up here again. We will see height of root dot left. Now, what do we mean by height root dot left? Now, when this is the root node, this will be root dot left. Now we will say call height D. Call height D. Okay, this is how recursion is worked internally with the help of a recursive call stack. Okay, now once we end up here, that means the two values it has further are none, or null, whatsoever you want to say. If we are talking about Python, we are going to say none. If we are talking about other languages, we are going to say it null. That means nothing. And this is our base case. That if now I'm going to write it. That if our root becomes none or null, we will return what we will return. What will be returned? In the chats, we'll be returning 0 because it does not have any height. This was the point we were receiving answers, remember? So this will be returned as 0. Okay? If root equals none, we'll be returning 0. This is the base case. Now, again, coming to the call stack, we did not make any further calls from here because this height calling with D gave us the answer 0. We again went back with answer 0, and this call was removed. Now again, we have come up here where we have called HB. We left on this line. Right? Where we were calculating the left height. Now we have to calculate the right height. This L variable is saved and it now has value of 0 for this B. Remember, now we have to calculate R. For R, we made a call. We again came up here at E because this was not none. Okay, because this was not none. Okay, and what actually happened at D? D tried to make different calls, but again, I'm coming up because I forgot to say that when we were at D, it did not give the answer directly. It made two more calls for this tree. This subtree had none. This returned 0. This subtree returned 0. D compared that both the heights are 0. Then it said that the actual height, the maximum of it is going to be 0, and it does not have any nodes further it can see. It won't be adding 1 to it, so it returns 0. Okay, this is the base case. Now we are coming up to E with this call, with the right call. It is going to give us the answer. It is going to make the other call G. So we have HE called, and then HE is making a call to HG. Now again, as we can conclude, the same thing is going to happen. G will return 0, 0 will be returned to E, 0 will be returned to E from this side. E will make a call to the left as well. Here it will see nothing. Nothing means none. It will be returned as 0 because of the base case. Now from one side, because G has said 0, its actual height will be added. It is E is receiving 0 from here, G is receiving 0 from both sides. It will be having here. E will add 1 here. Okay, 1 because it can see that it has 1 node in front of it. E will be returning 1 as the answer. Now B from two sides, it has 0, it has 1, it knows its actual height. The bigger one is this one. It will add its own 1 to it. It will make 2 and return the answer here. Okay, and this is how the call stack is working internally. I'm not going to be proceeding it further, but now I hope that you have gotten an idea how the call stack is working internally and how actually we are calculating. No matter how easy the program is looking, but internally it is working really hard to give us the answer. I hope you have understood all the illustrations that I have made. Quickly type yes in the chats if you have understood so far whatsoever I have said. And I expect everyone to write yes. Please be quick in the chats. All right. All right. Let's go to the coding window now. All right. We are having this function. Let's write code for it. Because this is G and E, it will become 1, right? Or we have to go to the illustration to see what's here. T goes here. At D, it will return 0. Like D will be having 0 as its own height. E will be having 1 as its own height. And then E will be returning 1, D will be returning 0. B will receive two answers, 0 and 1. D will compare those two answers. 1 will be greater. It will take that 1. It will add its own 1 to it, and then it will be 2, and B will be returning 2 as the answer to A. All right, Arushi, I hope that answered. All right. Now coming to this program, just confirm me if the font is very the font of the code is understandable to you guys or not, or do I have to increase the font? Is it visible to you guys? The font of the code, font size of the code, because we are taking under consideration the number of edges. It's going to be 3. Okay, but if the question, like I'm going to write the code in front of you, if it does not accept bit small, what bit small? If it is not going to accept the answer 3, then we'll add 1 to it because it is just one number like more. Whatsoever the height is, according to the number of edges, add 1 to it, it will be your height number. It's small. Okay, okay. Sorry. I asked the question and then I started answering somebody else. So let's increase the font. So it is already. Can we increase it a little more? I think not from here. Let me just zoom in like this. Okay. Is it visible now? Now we are going to design a function. Okay, and because we are in Python, I'm going to also show you that how we can end this question in one line, but after that. But after we write a very understandable code. Okay, so let's be very clear to it. I'm going to say, uh, uh, um, although a function is already made, but because this is inside a class, and for every recursive call that we make, I need to specify self and write longer. I'm going to take an easier way. I'll just say I'll make a variable h which will be having my height, or let's say the answer. Again, the way we go, and I'll say I'll create one helper function, and I'll send rule inside it. Okay, and I'm going to make this function with the global scope so that my function call is able to reach that function easily without the object. Helper, helper function, I'm just receiving the root node. Alright. Now we are going to write the function that we were thinking about. Okay. Also inside the main function, once this call has successfully gotten the answer, I'm going to return answer to the function. Okay. Base case at the end. Base case at the end. First thing, I'm going to create a variable. I'm going to make a call to the left subtree. How am I going to do that? I'm going to say root.left. All right. And then once this is done, I'm going to take right another variable. I'm going to store answer here, and I'm going to say root.right. All right. And then after this has happened, what do I have to do? Calculate my own height. I will get the maximum of L comma R. If both L and R are same, we are going to get any of the answer. Okay, and whatsoever is maximum, I'm going to add 1 to it, and that will be my actual height for the iteration, and then I'm going to return it as the answer. Okay, now talking about the base case, we can write it like this: if root is equal to none. If we want to go fancy, we can write if not two, both mean the same thing, and inside it we are going to return 0. Okay, we can either write if not root, or we can write if root equals none. Both the things mean the same. Okay, have everybody understood the code? Like you have already said yes to me, but just for the sake that I've written it right now, you can say yes, you have understood. Also, if you want one more explanation here in this screen, that how I have written the code, I can explain it more succinctly. But the thing is, you need to ask in the chats. All right, Pratik understood it. Manchu understood it. Anybody else? I am giving so much time to this question only because some people might be here who are studying trees for the first time. That's all. Sorry for all the people who might get a little bored because they already know about trees. I have to take care of everyone. Okay, are we good to go? Yeah. I hope this is going to give us an answer right away. Let's see. Okay, let me compile it. Yes, Pratik, it is right. When we do it in a BFS manner, we can do that. Actually, we are going to use that approach in the third question. Okay, not directly that approach, but a part of it is going to be used in the third question that we have. Okay, now let's see how this is going to go. All right, let us pass all test cases. Okay, we can make this code really shorter. Okay, we can make this code really shorter. Do you guys want me to write a one-line code for it? Do you guys want me to write a one-line code for it, or we can move to the next question? You can say yes if you want me to write one-line question, one-line code for it in the chats. All right, let's do it. Some people also said no. It won't take much time. Let's do it. Okay. What do we actually want? All this can be done in a single line. I was not writing that code directly because that could have been not understood by many of you. But now that we have it, let's do it. We can simply first take care of the base case, or we can write it here. If root, not root, if not root, return 0, else. Okay. That would require one more line. Just give me a second. Return 0 if not root. After traversing all the on line number 16. On line number 16, after traversing all of the nodes, then only it is going to be line number. It's going to be line number 17. Yes, that is how your TFS works. It goes into the depth unless there is no part to go, then it comes back. Okay. Okay. There was one comment deleted. I have deleted in this. Written 0 if not root, else now I'm going to write max of the two points self. This is how we call a function inside a class. Height or OOT F comma self dot T dot right and plus it is DFS. Yep, see, Pratik has already written that. We can do that or we can do that. Same thing. Let's run it. Give me the right answer again. Submit that. Give me the right answer. This is how, this is just a benefit of Python. You get to write one-line codes for anything. I hope you are able to understand this, what is happening here. Python is simply like English. You have to return 0 if there is no root. Else, what you have to do, you have to call two functions. You have to call the same function, that is your height, on the left subtree, then on the right subtree. Whatsoever value you get, you take the maximum out of it, you add one to it, and you return. Same logic in one line, and it feels exciting to me. That's all. That is why I've written it. Let's move to the next question. Okay, let me remove this string. Let me give you the link of the next question. Just a second. This is yet again a very interesting question, and it is going to take up some time to solve and some time to think as well. All right, guys. The question is there on the chat box. Go there, click on that question, read that question again. I'm giving you a break of 2 minutes. Read it, summarize it, and tell me what did you understand. All right. Now you must start writing in the charts. What did you understand by the question? The name of the question is diameter of a binary tree. And I'm not asking for the intuition right now. I'm just asking for what did you understand by the question. We are going to discuss the intuition later because I know some of the people will be writing a long comment and they'll be telling me the whole intuition. Okay, just one more minute and then we're gonna go solve the question on our own. Yes, yes, we will. Okay, I hope my screen is visible to everyone. Okay, just quickly, let's read the question. It says the diameter of a tree, sometimes called the width, is the number of nodes on the longest path between two end nodes. Okay, and by end nodes simply we mean the leaf nodes. The diagram below shows two such trees, each with diameter 9. The leaves that form the end of the longest path are shaded. Note that there is more than one path in each tree of length 9, but no path longer than the 9 nodes. Understood. Okay. One more thing, because I have not received much answers in the chat. I would want the people who read that question and was not able to conclude what this is asking and was not able to understand this question. They can just write in the chats that they can just plus one to it because I'm asking for anything. I just want to know the number of people who were not able to understand this problem. Plus one in the chats, please. Don't be shy when you are learning something. All right, Sahil, I'll be explaining. Okay, I need more answers, please. Be quick with it. All right, I'm reading the same. Yes. Okay, I don't know why very less people are active today. I believe two of the people who were driving my classes through are absent today. Only Pratik is there. Okay, no problem. Let's see this question again. Let me illustrate this to you guys. Just give me a second. Range shows that. Okay, let's do the question. right. We have these trees here. First, let's make our own tree, and then we'll discuss. Okay. Let's first work on a simple tree like this. Let's work. Let's just work on a simple tree like this. Okay. Now we are asking about the diameter. Now we are asking about diameter. What is the diameter? Or we can also say the width. It is the maximum path between two leaf nodes. Alright. Now if we see what the answer should be, what the answer should be. Cannot we say that let me get the height from this subtree and let me get the height from this subtree. The root is the connecting point. We add 1 of the root, okay, because this is the connection point, and then the whole number summed up will be given as the answer. Can we not say that? Can we or can we not say that? Yes or no? In the chats, yes or no? And if you didn't understand what I just said, just simply write, did not understand. Anything. I'm waiting. Alright. Yes, we can say that. No. Alright. Yes, seems correct. Okay. Let me tell you again. What do we want? We want maximum path between two leaf nodes. Right? If we are standing here on this node, if we are standing here on this node, can we ask this left subtree to give me the height? And we know that what is height? Height is the maximum path from the root node till the leaf node. It is a definition of height. Question is an example path, not passage. Yeah, I'm going to be coming to that. Don't worry. But for the sake of building the question in your head, let's first see this example. Alright, okay. That is why I did not started illustrating over the diagram that I just copied. I have made this here. Let's talk about this, then we are going to go ahead. For this question, just tell me, we know that the height is the length or the maximum length from the root node till the leaf node, right? If I just talk about this tree, if I specifically call the height function on this tree, both this tree will give me the height from this node till here. It will, right? This will give me the height from here. And if I do the same thing with this tree, this will give me the height from here. Maximum path from the root to the leaf node for left, maximum path from the from the root till the leaf node for right. We have the maximum paths from here and from here. If we combine them both with a +1, because this connection will be there, then can we not say that this is the maximum width? Then can we not say that this is the maximum width? Did you understand me, Prateek? Now, did you understand me now? What I'm trying to say? Did everybody understand it now? Okay, I'm waiting for some of the responses. Please increase the number of responses. There are like several people watching. Okay, if I'm only dealing to a bunch of people, let's go ahead. Thanks so much. Okay. Now once we know what intuition we have to go on, it might fail. It might fail at some points. The intuition that we have made might fail in some points. Assume now I have modified the tree. Now I have modified the tree. Then what is going to be the answer? Let's see. If I calculate it like this, if I calculate it like okay, um, if I again go with the intuition that I just told you guys, that intuition will give me answer the height of this tree, which will be 1, 2, 1, 2, 3, 4, right? It will be returning me 4. For this, the height will be, for this, the height will be 1, and combining it both, we'll add 1 to it. The actual height from this is going to be 5. Now I'm talking about the edges, okay? It is 1, 2, 3, 4. Oh, sorry. 1, 2, 3, 4, 5. And here it is going to be 2 more, 6 and 7. Then the answer will be 7. I'm counting the number of edges. We can also go by the number of nodes depending on the question. Okay, so for this, can we say that the width is 7? But is it the right answer? It is not, because if we are going to see this tree separately, if we are going to see this tree separately, then the longest path would be, okay, let me just increase one more here. Okay, then what would be the answer? 1, 2, 3, 4, 5, 6, 7, 8. This will become the longest path, and because I've just added this node, it is at the same level. It is not going to be affecting the height of it. The height is still the same. The 7 answer would remain the same, but from this separate tree, we will receive answer to be 8. And the question is asking for maximum width. It is not. It is not asking us to give us the width with respect to the root. It is not necessary. It is just a general condition, but it is not necessary for a diameter or a width to be passing through the root node. All right. Now have I made myself clear, Pratik? The confusion you were having, is it gone? All right. So these could also be the cases. So we have to design a function in such a way that it takes care of this. We will be, let me give you a hint, an idea of how we are going to code. We are going to design a function in such a way that it will be going through, it will traversing through the whole tree. It will be finding out all the possible diameters, and we for ourselves, we will be maintaining a global variable to keep the maximum value. And this will do the trick. This will get our answer. All right. Now, how many people can attempt coding it? How many people are confident enough? Write +1 in the chats. How many people are confident enough that after listening to what I've just said, my hint and the intuition, how many people are confident enough that they can write their own code to it? +1 in the chats. I want to know the number. That's all. Pratik is confident. Yes. Apart from him, Arshi is also confident now. Sahil is also confident. Great. Anyone else? People, please maintain the engagement. Anyone else? These three people, now I remember the name of Arushi and Sahil as well, and Himanshu. They have been constantly answering my questions. All right. Hmm. +2. You awake of? Great. Okay, now that we know what we are going to do, now we will be designing a function for it. Is it not? Okay, now can I just not discuss these examples or should I go with it? In this example, just confirming you the same case that either the answer that you are finding out could go through the root node like this, or it could avoid the root node as well. It could avoid the root node, and the answer could be formed in any subtree as well. Okay, this is just specifying that, and I hope that we have already made it clear in our own example. Let me erase it all. As me. All right. Now we will be focusing on designing a function. One thing more, we can either do a different height function and then we can call it, or we can simply make one function and modify it to be working as we want. I'm going to be creating only one function, but the way I explained you the intuition, if you want to go with that, that's also completely fine. You can make two functions, one separately for calculating the height, and you can use the height function inside it. I said height two times. One function you can use for calculating the width, the diameter, and inside the function, and inside the this diameter function, you can call height separately to find out the height of different subtrees. Up to you. But the function that we will be designing would be a single function in which we'll be doing both the things. Just give me a second. Okay. All right. So we have to create a function width dth width. It will be receiving the root again, correct? Because usually whenever we talk about trees, we receive only root. Okay. We are having the root. Now what do we need to do? Again, we will say the same thing is going to happen. The things that I said are simply all things that I'm going to put inside the code. I'll say get me the maximum width of the left subtree. Right? I'll say give me the maximum width of the right subtree. And once give me the maximum okay. I did not write left. Dot left and dot right. Okay. This happened. What I'll do? I'll figure out the current height. I'll figure out the current height. What will be the current height? The current height for this iteration, the current height will be L plus R plus 1. If we are taking in consideration that the height of this subtree is 3. That means we are counting the number of nodes because this is specified in the question. Had it been number of edges, it would be 2. But now we are counting number of nodes from this leaf to the other, so that the answer is 3. This will be giving us 1, this will be giving us 1, we'll be adding 1 ourselves, the connecting node. This is the current height. The first case that we followed when we were going through the root node. This is that case. Okay, current left plus right plus 1. Now what do we do? We will be maintaining a maximum variable. Initially it would be 0. Now I'll say that for my maximum variable, what you're going to give me, again, okay, let me just change it to, capital M because I'll be calling the function as well. Okay, this is my maximum variable. What do we need to store in the maximum variable? Whatsoever is the current value of maximum variable, comma, the current width. If the maximum width that we have been counting of a tree is bigger, let it be. If at the iteration that we have come to, if that has the height bigger than it, the width bigger than it, then it will be replaced. Simply. That just means, that just means if we are here, I have erased that big example. Okay, let us let's talk about this tree. This tree where we are not having a root. Okay, root node will have the current width of will have the current width of 1, 2, 3, 4, 5, 6, 6. But is that the answer? No. The maximum variable would be storing this part 1, 2, 3, 4, 5, 6, 7, 8, 9. The maximum would be storing 9. Okay, and that is when we will be talking about this subtree, and we will be seeing this subtree as a separate tree. This is the answer when we are seeing this subtree as a separate tree. Then the answer is 9, right? So we have stored that inside the m, the maximum variable. Once this iteration, once this recursive call is done, and we are again talking about with the perspective of root node, it will say that if I'm going to find the width, it is going to be through me, and through that the width is 6. But are we going to take it under consideration? No, because it is not bigger than 9. This is what we are going to do. And eventually, when we have run through the whole tree, we have taken every subtree under consideration, we have dealt it as a separate tree and find out its width, we will be getting the answer. We will be getting the maximum value inside the max variable. Now, does everybody understand me? People, are you with me? Are you catching up with what I am doing, what I am explaining? Are you able to figure it out? Everyone, please type yes in the chats. I'm waiting. Okay, Pradeep got it. Sahil got it. What about Arushi? She has been responding. Okay. Manshu also responded. Thanks for watching. Okay. So I do have audience which is continuously responding. Thank you so much, people. You have got how this question is working. That's right. Okay. We have this. All right. Now we need to take care about the base case. Now we need to take care about the base case. Okay, and once hold on. Once this is done, we have not yet returned the value. What do we actually have to return? Because our answer would be stored inside this maximum variable, we do not have to return the answer here at the return. But we are taking the first example that I showed you when the when the width was passing through your root. We have to return according to that. That means according to that, that means we are calculating the height and doing that. So for that, we have to return such in such a way that it calculates our height. What do we what we usually do with it? We have the maximum value from the left, we get the maximum value from the right, we add one to it. We have just done it previously, correct? The same thing. So this is the modification to the question, to the previous question, and the code is not much changed, just these two lines are changed, right? And now we have to add the base case. Base case is again going to be the same. If not root, if you are at the node which does not have any further nodes, that means you are at a leaf node. Okay, you are at a leaf node, it does not have any further values. Then what is going to be the width of it? 0. Okay, then the width of it is going to be 0. Alright. Okay, now I'm going to take a break of 2 minutes, and I would want that you guys go to the coding prompt and code this yourself. I have written the whole code here. Okay, I'm going to let it remain on the screen and take 2 minutes. Refer to this, write your own code in the code stub, and tell me if you're able to figure that out if the code is running or not. And just for 2 minutes, give me a break. I'm gonna get myself some water because I don't have it right here. Just 2 minutes. The code is open on the screen. I'm just not understood the return statement. Don't worry, Sahil. We'll be discussing it. Take 2 minutes break. Code it right now. All right, guys, I'm back. Being tracked in the charts, Sahil, I'm going to be taking up your problem. Don't worry. We are going to code it, then you'll understand. And for everyone else who have been attempting the code, tell me if you are making any progress. Till then, okay, till then other people are coding. Whosoever is having any problem, they can write up their query here. Write up your query in the charts. I'll take that. Waiting for you guys. If you have any query, please feel free to write it. Okay, so if everybody has already been attempting, let me try it as well. Here's the prompt. Let's see. Let's go. That'll be fine. I'll define a global variable m here. I'm not receiving any chat, so I hope the chat is not disconnected. Please just write yes so that I can proceed with the code. Just to let me know that you guys are still there, we can continue. Write yes in the chats, please. Okay. So I'm again going to do the same thing. Uh, I'll say that m equals 0 initially. I'm just resigning it. Okay. We'll do that later once we get a problem. Okay, m is a variable that eventually would be having my answer. I've created a global variable. What I'll do, I'll just again create a helper function which will take our root m and which will do all the changes inside m. And once that is executed, I'll simply return m. Okay, fine. Again, in the global scope, I'll define one function. I hope nobody is getting any problem in the language that I'm using because I'm using Python. You may or may not use it. Even if you want any of the references, of the Python specifically. If you do not understand any specific syntax, you can message me there. I'll give you the alternatives. Don't worry. Just feel free to speak up in the chats. That's all. Now we can say when you are telling life, when you are giving your time, make full use out of it. Get complete benefits out of it. Alright, we are getting the root. And now we have to design the root function. We have already seen how we did that. Let's see it again. Let's write the base case because we already know what it's going to be. I'm simply going to write it. If not root, then what? Then it will be return 0. Right? Okay. Now I'm going to say L equals LPR helper root dot left, and I will say R equals root dot R. Now, so I'll pay attention. I'm going to answer the question now. Okay. I won't do anything. I'll simply say return. Sahil, can you tell me what is this code for? What is this code for? We have just written this code in the previous question. What does it do? What does it give? Sahil, now asking to you. Sahil, this is the code of height. Yes, Arshi answered it. This is the code for height. Okay, because we are working on the intuition that involves the concept of height, this helper function is nothing but the code for a height, but we are making a little modifications to it, which will modify this question and will give us the answer to this new question, diameter. Okay. Yes, to get the height. Everybody guessed it right. This is the same function, and we are just adding up 2 more lines so that we can make it the answer to this diameter. This question asking for diameter. What we'll do? I will say current diameter. We will also say current diameter. Short for that. What will be the current diameter? The current diameter. Remember the first diagram. Whatsoever height is coming from the left, plus whatsoever height is coming from the right, plus 1. This is going to be your current diameter. And if this is your current diameter, do we need to pass on, the current diameter as the answer? The possible answer could be somewhere else. The possible answer could be present inside any of the subtree, not with just respect to the root. It could be present inside any of the subtree. We have seen the variation. For capturing that, I am going to use a global variable, and I'll just simply say max m comma current diameter. Now this what it will do when every this function will be finding out the width of every subtree, and whenever it gets a bigger value, it stores that. Okay, and no matter like whatsoever furthermore calls you are making, if you are unable to get that bigger value or a value even bigger than that as your width of the tree, then you are not going to change the maximum value. This m. I hope I was able to clear that again. Now let's see how it's going to work. Again, some of the Python specific things. If I am working on global variable, I need to mention global m inside the function so that the function know I'm talking about this global m, and I'm not creating my new m with a new scope. For this too, I'm going to do the same thing. I'll say global m. Okay, this would have been enough, but there is one more possibility, because this same code once written will be running on all the test cases. So it is possible that it passes on the first sample case, and when I submit that, it shows us it does not give the right answer. This is because when we are using a global variable, we have to be very careful with it, because once we have executed that in first test case, it will hold some value from that. And even if you go to the second test case, it is still going to be holding the value that you have that the first case had, and then it is going to mess up. So just for capturing that, whenever my diameter function is going to be called, that means for every new test case, I will again be assigning n as 0. As simple as that. For every new test case, we started from the scratch. M initially has the value 0. The moment it gets a bigger value, it keeps on storing the bigger value. That's all. All right. Now, let's submit that and run. Okay, it is running. Submit that. All right. Okay, yes, it is successful. Fine. Now, again, your turn. Tell me if you guys understood what we have done. First, tell me how was the question? Was the question good? This is one of the classic questions of trees. Was the question good? Simply tell me that. Sahil, Himanshu, Arashi, Prateek, and am I missing anybody else? Thank you so much for making this chat very interactive. All right, it is because of you guys. This is going for this. Everyone, please just tell me, have you understood that? Have you understood this question? Plus one in the chats, please. Plus one in the chats. Okay, Himanshu has understood it. It is a good question. Okay. Anyone else? Answer from Sahil, Anshi, I'm still waiting. And there are more people. I don't know why they're not answering. But I'm asking, have you understood this question? Diameter of a binary tree. Have you understood this question now? I'm just waiting for you guys to write plus one in the chats, and we'll be moving forward. We'll be moving ahead. Now got it after tracing the whole code. Good. That's great, Sahil. Even if you face any of the problem, tell me in the end of this stream, we are going to be solving it. Okay. Should I move ahead to the last problem of the day? It is a very good problem. We are going to discuss the intuition of it. I'm going to give you some hints, and then I expect that you take that problem home and you're gonna solve it. You are going to use your own brain. You're going to come up with different ways of writing the code. All right, that's going to be your problem. Ready for the next question? Plus one in the chats. If you're ready for the next question, just plus one in the chats, please. People. All right, Ashish is ready for the next question. Prateek is ready for the next question. Srinivas is back. Good. Srinivas, we were just going to begin with the third question, and this is a very interesting question. Okay, you're gonna enjoy it. We'll be discussing the approach to that. Firstly, we'll be discussing the question, then we're going to be discussing the intuition, and then I'll give you things. That's all. Okay. So now that everybody is back, I'm going to give you the link of the question. Just give me a second. problem is called burning tree. Okay, and it is a very interesting problem. Okay, I've posted the link in the chats. Click on the link, take 2 minutes, read the question thoroughly, then we are going to discuss it here. Burning tree problem on your screen. All right. Okay. We are just going to be starting with the third question. The problem statement is the problem link is given in the chats. Click on that, go to the problem, read it thoroughly, come back in the chats, give me the explanation, what you understood by the question. Okay. All right. Has anyone read the question? I've given enough time. Has anyone read the question? We need to find the maximum path from the target to any other leaf node. Okay, can be taken under consideration. Arun has joined. He is saying yes. There, he has read the question. Okay, let's read it ourselves. Pratik, till then, try thinking of intuition to that problem and post it in the comments. And same goes for Srinivas. Okay, the burning tree problem is shared. Height from the root to the target node value. Okay, Sahil, we'll see. We'll see nobody. So let's read the question. Given a binary tree and a node data called target, find the minimum time required to burn the complete binary tree if the target is set on fire. It is known that in 1 second, all the nodes connected to a given node gets burned. Okay, that is its left child, its right child, and the parent. Okay, the tree contains unique values. It is also given. That it simply means that target is not going to be two. Okay, there is always going to be one single target. Okay. Now that we have read the question, let's simply just go to the writing board and illustrate. Just click yes. All right, let's continue. So now we'll be discussing burning tree. Let's create a sample tree. Assuming this is a binary tree, and let's give it, let just give some values to it. Or okay, now assuming I'm taking this node as target, we are going to find a way to see that every node is going to have some value as a target. We will be receiving some value, some number value, or we can say integer value. We find that inside our tree. Very simple traversal of a tree. We'll figure out where the integer is. No, don't worry. Once we have figured out that this is our target, then what is going to be the further road approach to this question? First, let's understand this question. Okay, if you are standing here at the target, you need to give the minimum time to burn down the whole tree. If you are here, standing here, this is on fire. This is on fire. This node is on fire. After 1 second, this node and this node will be on fire. Okay, let me start like 1 second. This is zero. Okay. After 2 seconds, this node will light up this node and this node, correct? This does not have any further nodes to light up. After 2 seconds, this node will light up this node and this node does not have any further nodes to light up. Okay. After 4 seconds, this node will light up and after 5 seconds, these both nodes will and the tree will be completely gone. Okay, and the tree will be completely gone. Now in the chats, tell me, have you understood the question? +1 if you have understood the question. Please be quick. +1 if you have understood the question. All right, Pradeep has understood the question. Arshi has understood the question. Got that? Okay. Now let's see. Okay, thanks. I helped you got that. Let's erase it. Now let's talk about the intuition. If anyone has any sort of intuition in mind that how they can approach this question, they can state it in the charts. Okay, I would like to see different approaches to this question. Alright. Okay. So has anyone got any approach for this question? Who was saying? Tushar was talking about BFS. Try it with BFS. How are you gonna try it? Let me specify this. Okay. I've just made these arrowheads, and these are going to mean something. Use the height function yet again. Okay, we can do that, but it would be like actually I need a little more explanation that how we are going to use the height function. Yes, deep at the core, height is the answer, but how we are going to use the height function? Take a map to get the parents and then try with PFS. Alright, Shivam, you have gotten it like exact. This is what is the approach to this question. Adding height of all the ancestors of the target node. Adding height, yes, we can do that. But what if the target is what you can say is a middle node? That means it is not a leaf node. Then what? Adding height of all the ancestors. You add up the height of all the ancestors, but what if target is lying in the middle and it is not a leaf node? Pratik. Shivam is correct. We'll see what Shivam is trying to say. Don't worry. Adding height of all the ancestors of the target node. But what would that give us? If this is our target node and we are adding the height of all its ancestors, it's this and this. It will just give us two. Then what? Is two like are 2 seconds enough for it? Even if it will not even add the height of the ancestors. Okay, answer me, Pradeep, if I'm getting you right. Assuming this is our target node, what according to you is going to be the height of the ancestors? I'm waiting for your answer, Pradeep. If this is a target node, if this is a target node, what is going to be the height of ancestors as you are saying in the charts? 2 plus 3. Height of the ancestors. What all nodes are you considering ancestors? Because this is the parent, this is the grandparent, and only these both are going to be called as ancestors. Okay. If you calculate height till this ancestor, that means it will be 3, right? And this will be 2. So are you going to add these two? What are you trying to say? I am unable to conclude it. The root and its right child. Root and its right child. Yeah. Who are going to be the ancestors, right? And the root, okay, adding the height of this, the root, it is going to be 3, 23, and its right child is going to be 2. Okay. But what if I increase this tree here? What if I increase this tree here? Will whatsoever you are thinking, will it be fine? Tell me. Pratik, I increased this length. This is going to affect the answer. This is going to affect what we are thinking of, like the minimum time on the whole tree. 2 plus 5 then. Okay, 2 plus 5 then. Okay, 2 plus 5 then. Alright. Alright, alright, alright. Oh, let's see. Let's see. Oh, if it is just a basic. Maybe 1, 2, 3, 5. The height is 5. Done. The height is 2. Done. 5 plus 2. Will it be enough? For the 1 second, this gone, this gone. For the second, this gone, this gone. For the third, fourth, fifth, sixth, seventh. Alright, okay. This is giving the answer for this particular element. This is giving the answer for this particular element. But okay, Pratik, what you can do is you can try it on your own. It seems to work for the test cases that we have taken so far. Code it up, give me the answer. If it is passing all test cases, then it's completely fine. This is the acceptable solution. But I was thinking of one other solution using VFX. I'm going to discuss that as well. And yes, this is a healthy conversation. That is how we can make this live chat truthful. See, people are telling different approaches. We are discussing different approaches, right? Let's go ahead and also see the DFS approach, the BFS approach, sorry, that we were trying to. Also, the the statement that Shivam has posted. Take a map to get the parent and then try the BFS. Alright? For that, let's do it. We are going to understand it now. Okay, in general, if we talk about a tree, in general, if we talk about a tree, what happens? What happens? Can we go back to the parent node if we have taken a step ahead? A child node, a parent node have two connections to its left child and to its right child. Correct? It has two connections. But if we are talking about assume this node again, this node, it has connection to its child node, but it is also burning its parent. This node is also burning its parent. Yes, Pratik, I am discussing the same. It will be even better if you come up with a solution before I tell it. All right. Okay. For that, we are going to be making some modification in the problem itself. We are going to be making some modification in the problems ourselves. We have it in such a way that we can only move towards this way, right? Toward from the parents to the child. Can we do something so that we also have the reference to the parents note to the parent notes? What am I saying? To the parent notes. Would that work if we just make a data structure? Let's make a map or let's make a graph. Simply, let's convert this tree into a graph by using a map. What do I mean by a map? We can use a dictionary in Python or hash map in any language. What we can do? We can travel this whole graph, then we can know what node has which parent, what node has which parent. We can know that. Okay, we will keep a track of it. We will completely make a track of it. For every node to its corresponding value, we will store its parent. So the problem would become something like this. Okay, the problem would become something like this. This is going to be draining your mind in terms of using data structures. Okay, you need to be good with it, and that is what we are trying to do with this series. All right. So think it in this way. Once you think it in this way, the question will be modified in this form. Let me form a graph. Hold on. Okay, what modification will you? This is your target node. It has one node here. It has another node there. This node has this node there. This node has the root node there. The root node has another node here. This node again has two nodes. This one only has this node. This again has two nodes. This node, this node, and this node. Okay, these are the same values. Let me, for the sake of it, put in some values in it so that it is not confusing for you guys. Let's put some values. I said 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is my target node. I designed it in this way. This will be 7. This will be 2. This will be 5. With 2 is 1. This is your 1. I hope it is like completely visible to you guys. Okay. Then with direct connection with 1, we have 3. 3 has connection with 4, 7, and 8. We have represented this tree in form of this graph. Have everyone understood it till here? Have everyone understood it till here? Okay, this is a new problem. We have modified our problem. We have modified our problem. All right, now this is where it goes. It gets interesting. All right. Once we have converted this like this, again we know that this 6 is the point, is the target. Then we don't have to do anything. We just have to perform BFS. What is BFS? Okay, if I started explaining you what is BFS right away, it would take very long. But what you can do is you can go to JFG's channel. You can look for graph. You can look for graphs BFS. You will get a proper understanding of how BFS is performed in the graph. What do I mean by it? Okay, let me just quickly take an small example for you guys. Okay, let's. I'm going to do it very quickly. Okay, this is assume this is a graph, and all these cross sections that you are having, all these intersections that you are having, are the nodes of a graph. All right, and how you are going to traverse this graph if you are going if you are using BFS. Okay, I am going as fast as I can. Okay, okay, just this is small illustration. Okay. Assume you start with it. You start with this. Why to note the color change? Okay. You start with this node. Then when you are doing DFS, you are going to go to one single direction. Assume this. If you are unable to move further in this direction, then you will change the direction, and then you will keep on moving. Once you are unable to go further in this direction, then you will keep on moving. This is your DFS, and this is what we have been doing so far. What is the difference between this and the BFS? Let me tell you now. If you are standing here at this node, what will happen? Firstly, you will travel all of its neighbor. You will travel this neighbor, you will travel this neighbor, you will travel this neighbor, and then you travel this neighbor. This is your 1 second with respect to this question. In your 1 second, all these neighbors will be traveled. Then you go to each neighbor and you travel all the neighbors of that neighbor further. Okay, so assuming this was a neighbor you traveled first, then you are going to travel all of its neighbors. Done? Then talking about this is already traveled. We are going to travel all the neighbors that are left. Then we are talking about this. This neighbor is already done. We are going to travel this. We are going to travel this. Okay. This neighbor is left. This neighbor is already done. This neighbor is already done. This neighbor is already done. In this was your second iteration. Similarly, let's talk about this one. This one again has two neighbors. This traveled. This traveled. This traveled. That traveled. This traveled. That traveled. For this, these two also got traveled. Okay. For three, we got this traversal. I hope you are getting this question in this reference as well, because I am hinting you too much that how this question is now getting solved. In 3 seconds, we were able to figure out all these ways, like all these nodes that are burned. You can say it like that. Okay, now again talking about this node, we'll travel this. No other node is left. For this node, we'll travel this. Again, for this node, no other is left. For this node, we'll travel this. For this node, for this node, this is left. For this node, this is left. Okay. Again, in the next iteration, we are at the fourth. This will be done, and all the left nodes will be done in the next iteration. 5. It will take 5 seconds to burn the whole tree. If it was in this form, if it is in this form, you need to do the same thing, perform the same BFS. You will get like in what so many steps your BFS is getting over. That is going to be the number of seconds that you have to return as the answer. How many people have understood it? Please write it on the charts because I have explained it to the rest. Okay. Please write understood in the chat. You can do that for me. All right, I'm waiting. If you have any query, I'm still here. I'm here to answer your queries. Please put up those queries there in the chats. So we get a tree to graph using adjacency list, and then we have yes, Pradeep, that is exactly what we have tried to do using hash maps. Correct, correct, completely right. Okay, okay. Anyone else? Have they understood this approach? Even if you didn't get it right away in the first go, when the stream ends, try rewatching it. When you rewatch that, make sure that you pay your full attention. I won't be there directly to answer it, but don't worry. I always say you can get connected with me on LinkedIn and you can ask your queries there. I'll do my best to answer to each and every one of you. And I hope you have understood this. Apart from Pratik, can everyone else please say that they have understood because that gives me motivation. Okay, that's going to make me feel worth it of doing all of the work that I've done right now. Okay, so I'm removing the screen. All right, people, tell me if you understood all the concepts of this class. Have you understood all of the concepts of this class? Please don't delete this video after you finish. That is not going to be deleted. Don't worry, Anand. It is going to be there. One thing more, you can tell me how did you like? Did you like this stream? How was the stream? How was this lecture? You can show a little appreciation in the chats because I have worked hard for it. Okay. So if nobody has questions, we can try ending this stream. It was great. Don't forget to comment, not just in the chats, but just under the video, so that, by the way, I know that system of work example of the share actually, yeah, I was not able to think of that example right away. All right, it was good. We thanks, Sahil. Please comment down in the videos as well, not just in the chats, because that is where I get my motivation from. Pratik is the one who has been commenting constantly on my videos, and reading those really gives me motivation to make something even better, to come up with even more efforts for you guys. All right, I'll be ending the stream now. See ya. Good night. See ya tomorrow. I'll be coming at the same time, and we'll be discussing one different topic. I hope this video was good enough for you guys, and you learned from it. Please maintain the consistency. Whoever is following the 21 days habit builder, make sure you do not break it in this till this video you have come so far. Please make it till the end. And everybody who has been joining along with us after after a week or so, don't worry, continue it. You will just take 7 more days to complete. Don't worry, attend the live sessions, then get the recorded ones. Eventually, you are going to be seeing change in yourself with the habit. All right. Now I'll be ending the stream. You can just quickly write bye in the chats. Bye bye. Good night, everyone. Bye in the chats, and I will be ending it. All right, Sahil. See ya. Please make sure you guys comment and like the video as well. Well, I have till now I've gotten very less likes, so make sure everybody who is present here they like the video. All right. Bye bye. See ya. See ya tomorrow.